welcome to lecture number 70 on network analysis, and we have been discussing how to solve network problems which are having both dependent and independent sources. It is always better to explain the ideas in the form of some problem solutions. That is the better way to do it, because we know ultimately KVL, KCL somehow you have to write down in the equations. So, in my last class I took a very simple network and explained how to find out currents in the networks having both dependent and independent source. I will take another example to example 2 in continuation with first lecture, and this network is also simple, but let us do this exercise. Suppose you have a network which is I am drawing now, and there is a dependent voltage source present in this branch, which is written as V 1. What is V 1? It will soon come. That is, it depends on some voltage V 1 elsewhere in the network. So, this is a independent source 4 volt, and here is a 5 ohm resistance, and here is another dependent voltage source plus minus 2 I 1, and this I 1 is this one. Whenever if 1 ampere flows this way, it will be a 2 volt source coming into the network, and finally, here we have a 6 ohm resistance, and these are the 2 points where I would like to connect some load and find out the currents there, and this voltage is V 1 with this polarity. That is, whenever there will be a voltage across this 6 ohm resistance, in this branch a voltage with this polarity, this is plus, this side will be also plus, will appear in this network. And suppose you connect a 10 ohm resistance here, find out the current in the 10 ohm. So, I was telling you that better you find out the Thevenin's equivalent of this network. Of course, without finding Thevenin's equivalent, you can find the current in any branch you like with these two terminals connected with some impedance, that is always there. But let us try to find out Thevenin equivalent circuit across X and Y O terminals. I want to find out. So, to find out Thevenin's equivalent circuit, what you have to do is this: you have to first calculate the open circuit voltage, that is V x O with open circuit, nothing is connected across x O, that is the V Thevenin's. So, let us do first that. So, if you do that, nothing is connected here. Therefore, no current will be flowing in this network, in this branch 6 ohm. Therefore, voltage across 6 ohm will be 0. If that be the case, then to calculate V Thevenin's, this current being 0, no voltage drop across 6 ohm, this network will then look like 6 ohm here, and between these 2 points it should be then shorted, because V 1 is 0, and here is a 4 volt source. It is independent source, it will remain 4 volt. V 1 is 0, and this is 0 means 0 voltage between these 2 points, and here it is some 5 ohm, and here of course, the currents will be there. So, to find out V Thevenins, all the sources should be present, and I have taken all the sources. Here 6 ohm resistance is also there. Of course, there is no current here. Therefore, no voltage drop. V 1 is 0. V 1 is equal to 0. That is why this fellow is shorted. That is what you should understand. So, and this is 2 I 1. Is this current I 1 is 0? No. There is a closed path here. Some current will flow, and this current is 2 I 1. And I have to find out the potential difference between these 2 points. How do I find out V x o? I will start from O and try to reach x via any path I like, and whatever number will come, that will be the Thevenin's voltage of this network. So, while calculating Thevenin's voltage, you should keep all the sources in the network, both dependent and independent sources. That is what you should understand. Now, it is simply a series circuit here in this loop. There is no current. Current here is 0, open circuit. Therefore, currents will be in this loop only, and the magnitude of the current I 1, we can easily write it down as the voltage acting in the network in this direction, that is 2 I 1 plus 4 volt, 2 I 1 plus 4 volt divided by 11, because total resistance is series circuit 2 I 1 plus 4 volt divided by 5 plus 6 11. So, this means that 9 I 1, you bring it here 11 I 1 minus 2 I 1 is equal to 4. Okay, check the number, or I will say I 1 is equal to 4 by 9 ampere. I 1 will be equal to 4 by 9 ampere. This is the thing. And if I know I 1 is 4 by 9 ampere, current in this branch is now known 4 by 9 ampere. Current in this branch is also 4 by 9. Therefore, V x o, and therefore, there will be a voltage drop across this 5 ohm resistance, whose value will be 5 into 4 by 9, that is equal to 20 by 9 volts, is not? Therefore, and this voltage source magnitude also I now know 2 into I 1, that is 8 by 9 volts, because I 1 is known. So, V x o open circuit is your V Thevenins between point x and O. So, start your journey from O. So, there is a voltage rise of 8 by 9 volt, that is I first write it like this 2 I 1, then minus 5 by 1 minus 5 I 1. Then from this to this no drop. So, this will be then equal to minus 3 into I 1, which is equal to minus 12 by 9 volts, which is equal to minus 4 by 3 volts. So, this is the V Thevenins. I have found out. Now, I have to calculate R Thevenins. I want to express this network as a Thevenin's equivalent across X and O. So, I have to calculate the R Thevenins. So, to calculate R Thevenins, what you should do is this. Once again, please this you put it in your head, that while finding out the R Thevenins, dependent sources should be in the circuit, and it is the independent sources which should be replaced by their internal impedance. that is to find out Thevenin's resistance. What I should do, let me draw here, enough space is there. So, first to find out to find R Thevenin's, replace independent sources. Here only one independent source 4 volt, replace 4 volt by short circuit SC, and keep all the dependent source in the circuit, keep all the dependent source in the circuit. That is what first thing you have to do. Okay. So, the network then will then look like 6 ohm, dependent source I should not play with, let it be in the circuit. Here many students make mistake, sources should be replaced by their internal impedance. No, for if it is dependent, do not replace them, V 1. Then this 4 volt source I will short it here, this one, and this one is 5 ohm, and this one is another dependent source, it should be present in the circuit, and this current, if it is I 1, this voltage, that is what is given in the problem, 2 I 1, and then there is a 6 ohm resistance, and I have to calculate the R Thevenin's looking from XO of this network. Okay. So, 6 ohm, 5 ohm, 4 volt is shorted, that was the independent source. So, this one we will proceed further like this. So, this is the thing I require. I will copy it and go to next page and paste it. So, this is the, to find out Thevenin's theorem, we have this network. What was the value of this resistance? 6 ohm. So, somehow that was missed, 6 ohm. Now, here once again in case when circuit has only independent sources, we will be replacing those independent sources by their internal impedances. So, there will be only impedances present in the network, and therefore, R Thevenin's can be found out by series parallel combination of the impedances, equivalent impedance you have to find out, or by using star delta transformation, this that. But here it is not like that. I am not sure whether 5 ohm and 6 ohm in parallel, no, they are not. So, by series parallel formula or star delta transformation, it is not going to help you. So, there are two ways of doing it. One way is you excite these 2 points x and O, and mind you this is V 1, that is what it is given. I will excite these 2 points with a known source, maybe a voltage source, maybe a current source. So, I will excite this network with suppose an 1 ampere current source like this to find out Thevenin's equivalent. So, this current drawn by the circuit 1 ampere, and excite the circuit, excite the network from XO terminal, from X and O terminals by 1 ampere current source. This could be 10 ampere current source also, that you decide what you will do. 1 ampere current source, I have just chosen. This is a flexible thing, you can do whatever you like. With this circuit excited by 1 ampere current source, calculate Vxo now, Vxo now, which is not open circuit now. I have to calculate the potential difference between these two. Then if I know Vxo, I will say R Thevenin's will be Vxo divided by this 1 ampere, is not voltage by current. This is the voltage applied to the network, whatever you get, because across the current source voltage is not known, you have to calculate the other way around. So, this is how this will be the steps. So, essentially I have to calculate Vxo, voltage between these 2 points, when it is excited by 1 ampere current source. Clear? Now, if you are exciting this with a 1 ampere current source, the voltage drop across 6 ohm resistance is 6 volt, with this plus this minus, is not. Therefore, this network then will look like, with a different color I will draw, 6 ohm, this voltage dependent voltage source, and this is shorted because independent source. I am calculating R Thevenin's, this is 5 ohm and this is 2 I 1, that is fine, and this resistance 6 ohm, since you have forced a 1 ampere current to flow through it, the voltage drop will be 6 volt, 6 into 1 with this polarity. Therefore, that is equal to same V 1. So, this voltage will be also 6 volt. Got the point? This polarity you must understand, or alternatively you can write plus minus minus 6 volt. That is, I hope you know by this time what all this means. So, this is the circuit now, 1 ampere. What is my goal? My goal is to find out the voltage across this current source. That is the thing I have to do now. Okay. And this current I am telling it is 1 ampere. No, this is I 1. And this current is already known to be 1 ampere. Therefore, I can say the current in this branch in this direction should be 1 minus I 1 ampere, is not 1 ampere, I 1 goes. So, 1 minus I 1 must be flowing in this direction. Then what we will do? We will write down the KVL equation in this loop, mind you. In this loop, I will write down the KVL equation. So, if it is 1 minus I 1 flowing in this direction, then the voltage across this 5 ohm resistance, let me write in red, this will be 5 into 1 minus I 1. This will be the voltage across this resistance with this polarity, because 1 minus I 1 is downwards. Then write KVL in this loop, start from this point and let us try to write down KVL. KVL, I am not naming the loops, I am identifying the loop in this way. So, you understand. So, it will be then 2 I 1, start your journey from this point, from this to this minus 2 plus, then from this to this also minus 2 plus. So, write plus 5 into 1 minus 1, you reach this point, and from this to this voltage drop here will be I 1 flowing like this 6 I 1 plus to minus. So, that must be minus 6 I 1, it is like this. Then once again minus to plus, and that is 6 volt plus 6 B, you do not write, everything is in bold, B is no. So, plus 6 volt, and that must be equal, and you have reached this point. So, this must be equal to 0, that is the thing. So, what you have got is 2 I 1 minus 5 I 1 minus 3 I 1 and then minus 6 I 1. So, it will make it minus 9 I 1. And what are the constant here? Constant will be plus 5 plus 6 plus 11, and that is equal to 0. Therefore, I 1 is equal to 11 by 9 ampere. Once I know I 1, I will be able to calculate V x O. Mind you, this is so. Therefore, I will say V x O in this network, potential difference between these two. Start your journey from O and try to reach x via this path. So, V x O will be 2 I 1 minus 2 plus, then plus this voltage plus 5 into 1 minus I 1, and from this to this it is a voltage rise of plus 6 volt, and you have reached point x. That is what V x O. This is no Thevenin's voltage, it is the voltage existing across the current source. So, this one will be 2 I 1 and minus 5 I 1 means minus 3 I 1 it will be, and plus 5 plus 6, that is plus 11. And so, it will be 11 minus 3 into I 1, which is equal to 11 minus 33 by 9, because I 1 is 11 by 9. Is it correct? So, this will be actually 11 by 3, and if you calculate, it will be minus 22 plus 22 by 11, 22 by 3. So, this will be 22 by 3 volts. See, once you have got this V x O, I will tell R Thevenin's, whoever is looking into it, this voltage now I have calculated, let me use different color. This voltage x plus and this is minus, this voltage now I have solved. This voltage is 22 by 3 volt. So, I will say this network is drawing 1 ampere current when 22 by 3 volts is applied between x and O. Therefore, what should be R Thevenin's? R Thevenin's should be then V x O by 1 ampere. V x O I have now calculated. So, 22 by 3 by 1 is equal to 22 by 3 ohm, that is all. So, this is the R Thevenin's value. Therefore, in the previous thing we have calculated V Thevenin's, which is equal to minus 4 by 3 volt, and now R Thevenin's is known. So, V Thevenin's already calculated, calculated. To be VXO open circuit equal to how much? Minus 4 by 3 volts, minus 4 by 3 volts. So, this together with this, I will be able to draw the equivalent Thevenin's across point x o. So, therefore, equivalent Thevenin's circuit across x o is how much it will be. So, V Thevenin's is minus 4 by 3. So, two ways you can write R Thevenin's. R Thevenin's is by 22 by 3 ohm and VXO is minus 4 by 3 volt. So, it should be shown like this. And this is your point x and this is your point O. Whatever impedance you now connect, you will be able to calculate the current. Alternatively, what you can do is this 22 ohm, 22 by 3 ohm, Thevenin's resistance does not pose any problem. V Thevenin's with this polarity you only write, but while writing this magnitude you must write this is minus 4 by 3 volt. Then this is x, this is they are one and the same thing. These two you must understand, because potential of x with respect to O I have got to be minus 4 by 3 and so on. This is the one way of solving the network. Now, what I will be doing, so you have got the idea. The point to be remembered is while calculating R Thevenin's, you should not remove the dependent sources. Only independent sources should be replaced by their internal impedances and excite the network through the points where you want to find out R Thevenin's with any known source, maybe a current source, maybe a voltage source, it does not matter, but do that and then replace the dependent sources by their internal impedances and solve this network. So, if you have excited it with a current source, you must know what is VXO now to say what will be Thevenin's impedance looking into these points. Another way I told you that you have already calculated V Thevenin's, you have got it. That is what I will also do for this network. So, open circuit voltage you calculate like this. Then what you do, you calculate the short circuit current, that whatever will be flowing. So, this another way of doing it is to calculate the short circuit current. If x and O are short circuited, if I can calculate that current, then this open circuit voltage divided by this short circuit current, which I am going to find out, will also give you R Thevenin's. It is a good practice to do that. It will then make your understanding much better, that in any case you must come out with a unique value of Thevenin's voltage and Thevenin's resistance. So, what you do is this, you I will copy this network. Now, R Thevenin's I have already calculated. So, I copy this and go to next page. And paste it. That is, suppose I ask you this point is O. I think all parameter values as this was the original network. Ask you what is short circuit current when X and O are short circuited. This current is how much? I want to find out. Got the point? This is the short circuit current I want to find out for the same network, and this is the complete network. So, I have to solve this network and get the value of the short circuit current. So, what do I do? You note that this point is X, this point is A, this point is O. Now, voltage across X O, because you have short circuited, it is equal to 0. So, first thing you note that V A O has to be equal to V 1 itself, because this point is now same as this point. So, the potential of this node with respect to this point is nothing but V 1 itself. Clear? Therefore, we can say that ISC, this current, is nothing but V 1 by 6. V 1 divided by 6 is this current. So, this is one equation. What are the unknowns in this case? ISC, V 1 and I 1, 3 unknowns are there. So, these two are related by this simple logic. Now, if that be the case, then what you do is this, you write down the KCL at node A or 6 I 1 plus 4. Okay. So, V 1 is equal to V A 0. What you do is write down KCL at A, KCL at node A. What will be it? This is V 1. So, V 1 plus 4 minus V 1 by 6, is not. And do not while finding out short circuit, do not keep all the sources present, because I am not going to find out R Thevenin's. I will find out R Thevenin's in a different way, that is what I am showing. So, it will be V 1 V A 0 is nothing but V 1 itself. So, V 1 plus 4 then once again minus V 1 divided by 6 is this current, is not. And this current I am telling this is equal to I 1. For example, this is not KCL, this is true na. In this branch this current is like this. Therefore, I see I 1 is straight away known. I 1 is equal to then 4 by 6 ampere, that is equal to 2 by 3 ampere. I 1 immediately can be found out. So, now I know I 1 is also known, and for this I did not apply KCL, just this branch current in terms of the voltage across this branch acting is how much? V 1 plus 4 minus V 1 with the polarity. So, I 1 is known. Okay. Then you apply KCL at A, KCL at A. It will be equal to current in this branch, and that is already known 2 by 3. KCL current in this branch, this will be plus V 1 in this branch, V 1 minus 2 I 1 by 5 is this current, and this current is V 1 by 6, and that must be equal to 0, because these two are shorted. So, the voltage is V 1, is not. So, but I 1 is known, I 1 is that 2 by 3 ampere. So, we write 2 by 3 plus V 1 minus 2 I 1, that is 4 by 3 by 5 plus V 1 by 6 is equal to 0. V 1 is to be calculated to find out ISC, because ISC is V 1 by 6. So, we are almost at the end of the problem. So, that is the thing. So, what best you can do to solve this circuit? Multiply with 30. So, therefore, if you multiply with 30, it will be 20, and plus this will be 6. So, 6 V 1 minus 4 by 3 into 6, these two terms, and plus V 1 plus 5, you know, and that is equal to 0. So, you get from this that 11 V 1 will be equal to minus 20, 20 you bring it to this side, and this is plus 8. Or V 1 is equal to minus 12 by 11 volts. This will be V 1. Is it correct? Then ISC, short circuit current, is V 1 by 6. So, minus 12 by 11 divided by 6 is equal to minus 2 by 11 ampere. ISC will come, ISC is this much. Then I am telling R Thevenin's should be V XO, open circuit condition, that is Thevenin's voltage, divided by ISC, that is V Thevenin's divided by ISC. And V Thevenin's, how much we got? Minus 4 by 3 volts. So, you put those numbers. So, minus 4 by 3 divided by minus 2 by 11, and this once again will become equal to 22 by 3 ohm. So, in whichever way you do it, but do it correctly, what I am telling, because when dependent sources are present, this is the challenge. You should be very careful what you are doing. One way of finding currents in any branch of the circuit, do not go even to Thevenin's theorem, you just solve the network as it is. For example, in this network, if I find out all the currents, I have never calculated any Thevenin's. All the branch currents can be calculated by simply writing KVL and KCL. Hope you have understood this. Some more problems with the dependent current and voltage source I will try to upload, and please go through them, and also you solve problems from books whatever is available with dependent source, not too complicated circuit, but at least simple circuits you do, it will give you confidence. Hope you have understood the basic idea how to handle networks having both dependent and independent source. In my next class, I will start new topics, that is 2-port networks. Thank you.